Welcome back. I'm Muggsy, and today I'm going to explain valence electrons. In order to explain valence electrons, I think you also need to know how to construct a Bohr model of an element. So if you haven't learned that, go and check out my video on that first. But valence electrons are just the outermost electrons in an atom. So in order to determine what those are, we should just kind of visualize an atom. So let's start with a nitrogen atom. Nitrogen has an atomic number of 7. So that means in the nucleus of a nitrogen atom, there's 7 protons. It has an atomic mass of 14. So 14 minus 7 leaves 7 neutrons in that nucleus. And then because it has 7 protons, it also has 7 electrons. Now, as you may remember from earlier, those electrons orbit the nucleus in distinct energy levels. And that first energy level, that first orbital, can only hold 2 electrons. 1, 2. But in a stable nitrogen atom, you would expect to find 7 electrons because it has 7 protons, and a stable atom is neutral. That means the number of positive protons is equal to the number of negative electrons. So therefore, if we have 7 total electrons and 2 of them can fit in that first energy level, that leaves 5 for the next energy level, which can hold up to 8. So let's put our 5 electrons in there and kind of space them around equally. Boom. Okay, now these 5 electrons are our valence electrons. And there are 5 of them. Again, valence electrons are just the electrons in the outermost energy level. Whatever's in the earlier energy levels, we're going to ignore. We're only going to count the ones in the outermost energy level. Now, the reason we have this concept of valence electrons is because it's only those outermost electrons that are involved in ionization and bonding and all the different chemical processes that go on between atoms. You'll learn about these later. The important thing is just to remember valence electrons are the electrons in the outermost energy level. So if I were to ask you how many total electrons does nitrogen have, you would say 7. And if I were to ask how many valence electrons does nitrogen have, you would say 5. Okay, let's look at a more complicated example now. Let's think of the element calcium. Calcium is a bigger element than, what's the last one we looked at? Nitrogen. And calcium has 20 protons in that nucleus. It has an atomic mass of 40. 40 minus 20 leaves 20 neutrons in the nucleus. If it has 20 protons, and we're talking about a stable atom here, then it must also have 20 electrons. So let's go ahead and put those 20 electrons in their various energy levels. So that first energy level can hold 2. Now, I'm worried about making a mistake as I construct this Bohr model. So as you may recall from my Bohr model video, what I recommend with your electrons is just keep a running tally. So let's say we have 20 electrons and I put 2 in the first energy level. That leaves 18 electrons. Okay. You'll also remember from my Bohr model video that every energy level after the first can hold 8 electrons. So let's put in 8 electrons in this second energy level. 1, 2, 3, 4, 5, 6, 7, 8. Which leaves 10 electrons remaining. Okay, the next energy level can also hold 8. And we have 10 left to go, so let's put all 8 in that one. There they are. Okay, and that leaves a total of 2 electrons. Now the next energy level further out can also hold 8 electrons, but I only have 2 left, so let's just put both of them in that energy level. Here's one, and here's another. Okay, so since I'm out of electrons, I know what my outermost energy level is. It's this one here. And I can just count the electrons that I put in there. I put 2 electrons in there. So calcium has 2 valence electrons. How many total electrons does calcium have? It has 20, all of these. But how many valence electrons does it have? It has 2 valence electrons. So it's pretty easy to count. Okay, now that I've shown you with Bohr models, I'm going to teach you a much easier way of predicting the number of valence electrons for an atom. And that is using the periodic table. So take a look at my learnsomething.app periodic table here. And you can see everything in this first column, hydrogen, lithium, etc., all the way down. They all, if you were to draw a Bohr model of each of them, you would see that they all have 1 valence electron, 1 electron in their outermost energy level. If you look at the second column, beryllium, magnesium, calcium, these all have 2 valence electrons. Skip the D block and the F block, the intertransition metals and the transition metals, and move over here to boron. This is column 13 or 3A of the periodic table. All of these guys have 3 valence electrons. Carbon, silicon on down, they have 4. Nitrogen on down, they have 5. Oxygen's column has 6. Fluorine, chlorine, bromine, the halogens, they all have 7. And the noble gases, helium, neon, argon, they're all full. Now this one's a little bit tricky. Helium has a full outer orbital, but it's so small it only fills the first orbital, which can only hold 2. So helium has 2 valence electrons, but every other noble gas, neon, argon, krypton, etc., they all have 8 valence electrons. So this last column's a little bit tricky. They're all full, but helium fills up earlier than everything else because that first energy level can only hold 2 electrons. So helium has 2, the rest of them all have 8. So basically, whatever column we're talking about, excluding the middle there, that's how many valence electrons that element would have. Now, what about the middle? The middle's really tricky. I can't tell you how to predict the exact number of valence electrons for these transition metals and intertransition metals. And in fact, no one can. Someone might have them all memorized, but you don't really need to. For these guys, we tend to tell you how many valence electrons they have by writing out oxidation states, which we'll get to in a later video. But for now, you can just kind of ignore those and know that they don't follow the same pattern as the representative elements, the elements on the wings of the periodic table. That's columns 1 and 2, skip the middle, and then 13, 14, 15, 16, 17, 18. For all of those elements, you can just look at the column number, and that'll tell you roughly how many valence electrons they have, 1, 2, and then skip to 3, 4, 5, 6, 7, 8, with the exception of helium, which fills up at 2. Okay, that's a lot to take in. I think the best way to practice this is just to start with some problems and start predicting how many valence electrons you think these various elements will have. I hope this helps. Once again, I'm Muggsy. I'll see you next time. And if you want to practice determining the valence electrons of an element, just head over to my app, learnsomething.app. You can practice this and many other chemistry skills. I'll show you a Bohr diagram of an element, and then you tell me how many valence electrons it has. As with all Learn Something skills, they'll get more complicated over time, and when you fill up the bar entirely, you'll have demonstrated complete mastery of that skill. So once again, that's learnsomething.app. Head over there and start practicing today. Thanks again for watching.